our warm-up, we were asked to find the volume of two three-dimensional shapes. Our first shape is a cylinder, and our second shape is a cone. Anytime we are finding volume or anything that applies to formula, we should always start by writing down our formula. So looking at our green formula chart, we should have looked for volume of a cylinder. And according to our formula chart, you would notice that it said volume is equal to capital BH, where you have to remember what that capital B stands for. So just a little reminder to ourselves, capital B stands for area of the base. Now, the shape of the base of a cylinder is a circle. So we can actually replace that capital B with the formula for area of a circle, which again on your formula chart you would find is pi r squared. So we're going to plug in each of the parts of this formula into our warm-up. That way we're able to calculate the volume of the cylinder. We're going to start with volume is equal to, we can leave pi as pi. Next we need the radius squared. So looking at my cylinder, I have to identify what part of the base they gave me. So looking at that circular base, I noticed that the line goes from the center to the outside edge, meaning they already gave us the radius. The radius is 3.4 feet. So we have pi times our radius of 3.4, but we have to square that. And we're going to multiply that by the height of the cylinder. Now, as a reminder, anytime you're finding height, the height is the distance between the bases. So going from one circular base to the other is 12 feet. That means their height is 12. Now, let's simplify the radius squared. Using my calculator, 3.4 squared is 11.56. So I have pi times 11.56 times 12. And then now I'm going to type all that in together. So I do the pi, which again is second here at top, times 11.56 times 12. And I get an answer of 435.8. We have to include our units. This was in feet, and volume is always units cubed. Now, I'm going to back up just a little bit. Here in this first step, we can actually type that into our calculator as is. So I could type in pi times 3.4 squared times 12. And you'll notice that we get the same answer. And moving forward, it's okay if you just go ahead and type just this into your calculator. It helps avoid any rounding errors. It helps avoid a typo as you're working your way down. So in the future, it's okay if you just go straight from plugging into the formula to finding the value. All right, moving on to our cone. Once again, we should start by writing down our formula. I know last time we were together, we got to go outside and do an experiment looking at the relationship between a cone and a cylinder who have the same shape base, the same size base, and the same height. And we discovered that we were able to fill up the cone and pour it into the cylinder 3 times. That meant it took 3 cones to fill up the same cylinder. In other words, the cone was a third the size of the cylinder. So whenever we're finding volume of a cone, it's 1/3 area of the base times the height, which I would have found on my green formula chart. Looking for volume of a cone, it states V equals capital B H, where once again that capital B stands for area of the base. Our base is a circle, so I can replace that capital B with pi r squared, because area of a circle is pi r squared. So then once again, I'm going to plug each of these pieces in. I have volume is equal to 1/3 times pi times, I need to find the radius. When looking at the cone and looking at the circular base, I noticed that the dimension goes from the center to the outside edge. That means they already gave me the radius. Our radius is 5 feet. So I have 1/3 times pi times 5 squared times, next I need the height of the cone. So the height of the cone is going to go from the base all the way to the tip of the cone. So this cone has a height of 9 feet. I'm going to simplify that 5 squared. Well, 5 times itself, or 5 squared, is 25. So in our next row, we have volume is equal to 1/3 times pi times 25 times 9. So then now utilizing my graphing calculator, to put that 1/3 into my calculator, I like to put my fractions in parentheses. So I have parentheses 1 divided by 3 to make 1/3, close the parentheses, pi times 25 times 9. And I get 235.6. My units were feet, and volume is always cubed. So once again, I'm going to show you that as soon as you plug your parts into your formula, you can actually type that immediately into your graphing calculator. So I can type that as parentheses 1 divided by 3, close parentheses to get that 1/3, times pi times 5 squared times 9. And you'll notice we get the same exact answer. It just eliminates the possibility of making an error whenever you square the radius. All right, so that was the warm-up. I do want to make sure that you see the tips on the screen for when you're solving cones or cylinders. Don't forget, when you're looking at that circular base, if the length is next to a line that goes all the way across, that's the diameter. Versus if the length goes from the center to the outside, that's just the radius. Whenever we're finding volume of a cylinder or a cone, both of the formulas specifically ask for a radius. So if it goes from the midpoint to the edge, you're good to go. However, if the distance, let's say this one said 8 inches, if you see the dashed line go all the way across the circle, don't forget that's the diameter. So the diameter is 8, meaning that the radius is 4. Okay? Good luck today, and I'll see y'all on Friday.